Hello everyone, myself Snehal Shinde, lecturer in Pravin Patil College of Diploma Engineering and Technology from Electrical Department. Subject is Utilization of Electrical Energy. Subject code 22626, Unit 4, Electric Traction. So the traction motors used are the DC series motor. So here is the characteristics of the DC series motor. It is plotted between speed and torque. So the suitable speed torque characteristics, the speed torque characteristics of DC series motor are shown. So for high torque T1, the speed is low N1, and the low torque T2, the speed is high, that is N2. This is the exact requirement of the traction system. At start, heavy mass of train is to be accelerated, so torque required at high and speed should be low, so T1 into N1. As the train gathers the speed, momentum is developed, speed increases, and the torque requirement decreases. So T2 into N2. Second is the parallel running. Due to the step speed, torque characteristics, the parallel running is effective. So even if there is a difference in the mechanical load on the motors, there is no drastic difference in the current taken by the motors. So DC series motor gives good performance for a parallel running. Voltage fluctuations. The torque produced is not much affected due to the supply voltage fluctuations. Temporary interruption of the supply. The supply interruption takes place at the tunnels, bridges, and usually down gradient is present, so the motor can easily cope up with the temporary interruption of the supply. Overload capacity. It can sustain overloads effectively. There is not much increase in the current even if the load increases. Self-relieving property. So the output of the motor is given in HP. Output equal to 2 pi nt divided by 60. That is, output is directly proportional to the torque into the speed, or HP is directly proportional to the torque into speed. So for the series motor, N is proportional to V divided by IA. So next we will see HP is proportional to T into V by IA. So the torque is proportional. Also we know that torque is proportional to the IA square, and we know that IA is proportional to the root of T. Then HP is proportional to the T V by root T. So HP is proportional to root T into V. And from the above equation, we can say that for the given increase in the torque, there is not much increase in the HP rating. This is called the relieving property. Next property is the speed control. The speed of DC series motor can be controlled effectively by the various methods like series parallel control, bridge transition method, solid state control, electric braking. There are some issues while carrying out the regenerative braking for the DC series motor. Additional components and changes in the circuit connections are needed For the regenerative braking, weight and size, the DC series motor has a moderate size due to the commutator. The axial length is somewhat more. It is robust and efficiency it is good at the different loading conditions. In case of DC series motor, T is proportional to phi into Ia. T is proportional to Ia into Ia since phi is produced by Ia. So phi is proportional to Ia, therefore torque is directly proportional to Ia square up to the magnetic saturation. For the shunt motor, torque is proportional to the phi into Ia. So the T is proportional to Ia only since phi is constant. Thus for series motor, T is proportional to the Ia square and for shunt motor T is proportional to the Ia. If the torque requirement increases, the series motor will draw less current compared to the shunt motor, that is drain on electric current is less in case of the series motor. AC series motor, the traction application requires steep speed torque characteristics. The DC series motor fulfills this requirement and hence it can be used for the traction work. The AC series motor characteristics is similar to the DC series motor. The construction of AC series motor is almost similar to the DC series motor, but some modifications are done, that is, compensating winding is used. The motor is operated at a lower flux density to reduce the iron losses. Air gap is very small to reduce the magnetizing current. Field system or core is laminated to reduce eddy current loss. The motor is operated at a lower frequency, that is 25 Hz or 16.66 Hz. Due to this, commutation is improved. Also, efficiency increases. Shunted compoles are used. The size of AC series motor is almost twice of the DC series motor of the same capacity. The power factor of the AC series motor is poor during the starting, so the starting torque is somewhat less. The maximum operating voltage is 400 volt. In case of traction, the AC series motor is used for the mainline services where moderate acceleration is required. It is not used for urban and suburban service where high acceleration is required. Next is the chopper controlled motor. So DC chopper, it is a static device that converts fixed DC input voltage to the variable DC output voltage directly. A chopper may be thought as a DC equivalent of an AC transformer since they behave in an ideal manner. A chopper can be considered as a high-speed on-off semiconductor switch. It connects and disconnects the supply to a load at a very high speed. So here is the chopper operation shown and the chopper waveform. The chopper is represented by a high-speed switch. Its switching time can be decided as per the requirement, that is T on and T off can be controlled as per the requirement. During T on, the chopper is on and the load voltage is equal to the source voltage Vs. During T off, the chopper is off that is switch is open, the load current flows through the freewheeling diode. Thus, load terminals are shorted through the freewheeling diode. Hence, load voltage is 0 during the T off, but the load current continues to flow during the T off. The average load voltage comes out to be V0 and it is shown by the dotted line, that is V0 equal to T on divided by T on plus T off into Vs. So T on divided by T Vs. So it is denoted by alpha into Vs. So T is the chopping period, alpha is the duty cycle, V0 equal to alpha into Vs. Thus, load voltage can be controlled by controlling the duty cycle alpha. A separately excited motor is convenient to use, that is, field winding connected separately across the supply. Both armature and field motors winding receive supply through the thyristor chopper. By varying the duty cycle alpha, the voltage applied to armature and current through field winding can be controlled independently. Thus, speed control is possible. For switching off the thyristor during T off, a thyristor commutating circuit is used. The freewheeling diode maintains the motor current during the T off. The thyristor acts as a fast switching device chopper. This may cause a lot of electrical interference with the neighboring circuit. So a line filter is used which prevent this interference. So here is the positive DC overhead line and the negative return through the wheel and running rail. So in this mode between a AC locomotive with the tap changer control of a transformer output is there. So the pantograph is connected to the circuit breaker. Then after circuit breaker, it is connected to the transformer. Then there is a line filter element. It is capacitor. So it prevents the interference. Then a thyristor is used, armature thyristor. Then a thyristor commutator circuit. And in series a thyristor is used. Then a freewheeling diode is connected in parallel. Then we have uses separately excited DC motors. So the excitation is made DC excitation by the thyristor control motor fields winding. So this winding takes the DC current and it get excited. Then the axle brush is provided to the negative return through the wheel and the running out. So this way a chopper circuit is uses. So we can control the duty cycle effectively. By varying the duty cycle, we can adjust the output voltage V0. So here the Vs will be constant, that is the supply voltage, and V0, that is the output voltage, is variated by the duty cycle. Duty cycle is it is given by the equation of the T on upon T. So this equation is the duty cycle, that is alpha. By turning on the duty cycle, we can make the changes. So for switching off the thyristor during the T off, a thyristor commutating circuit is used. Commutation means off. For off or to turn off the thyristor, the commutation, that process is known as the commutation. So we will use the thyristor commutating circuit. And the freewheeling diode maintains the motor current during the turn off, when it is turned off. Thank you.